Hello guys, welcome. We have just tackled the reactions, shear force and shear force diagram. We have already sketched it out, so hope you're remembering this question. And now we are remained with calculating the maximum bending moments and sketching it. So please be tuned. Let's complete this question. So let me turn this. For the bending moment, so here the maximum bending moment will occur where the loads act. So the maximum bending moment for the span AB, when I mean span, I mean this one, the distance between A and C, will occur as C at point C, and the maximum bending moment for the span DB will occur at the center. So we have to introduce a center here. You have to introduce a center where maximum bending moment will occur, but we can just draw it fade that way. So we have to calculate. So when calculating the maximum bending moment, no, it's number 3. Calculating maximum bending moment. So for the span, I'd say so for this beam, continuous beam, we know that the bending moment at A, the end A and the end B are 0 because the beam is simply supported, or the beam is hinged. So bending moment at A is equals to 0. Bending moment at B also is equals to 0. So we are remain with bending moment at C and bending moment at D. It's just simple. So bending moment at point C. So you can consider any side. C will be your reference point. You can consider any side. You can consider end A or end B. But for now, for you to be fast, you have to consider the ends or the side carrying the less loads. For example, for our point C, we'll consider the end, the side, this left side, because it's carrying just few loads. But even if you consider the other side, the bending moment will be the same. We can still do both sides to confirm whether the bending moment will be the same. Okay, let's continue. Let's start with point. Let's start with side A, this side, left side, I mean. So bending moment at C equals to, so this load, because we are looking for the bending moment at C, this load will not act at point C because that's where our reference is, and that point, that load cannot have any effect there. So you'll just look for any load that is either on right side or left side of that point, but that these 50 kilonewton will not affect our bending moment. So we'll have to take this side, the which is carrying the less load, and the loads that we have here, it's upward loads, which is reaction A. So we'll have reaction A times the distance, because this is our reference points is 2, and we know our reaction A is 57.5 times 2, which is 52.57, I mean 0.2 multiplied by 2. okay, 57.5 multiplied by 2, we have 115 kilonewton per meter, because it's moment. But when we also need to consider the right side, to see if we can still have the same value. So let's consider this side. These are we are looking for the moment at C. So considering this is right, okay, this is the right side. So we'll have reaction A multiplied by reaction B, multiplied by this distance, which is 6, 72.5 multiplied by 6. I'm just showing you. So plus, you can do it and see the same, plus this load, UDL load, which is 20 multiplied by 4 multiplied by 2, which is 4/2 to make it point load, plus this distance, plus this distance, plus this distance. So you have to be very careful there. You have to be very careful. First you have to multiply. So it will be 20 multiplied by 4 multiplied by 4/2 plus 2. So you have to key this on computer, on calculator, then to multiply by this, then to multiply by this. So is 2 plus 2, that's 4, times 4, that's 16, times 20, that is, okay, sorry. So for this we have 16 multiplied by 20. We have 320, and so this is 320, but it is a negative because it's downward loads. Then we have a positive, which is 72.5 multiplied by this distance 6. We have a positive 435. We minus 1. We minus 320. Yeah, and we have 115 kilonewton. So it's just the same. I've just done that to just show you. You can take any side, but at least make sure you have taken the side with lesser loads, number of loads, because it will be easier for you. So let's calculate the moment. Bending moment is 8 point D. Yeah. So when we have the point bending moment at point D, so D is our reference point. So we'll just take this side with the fewer load. So we'll just have a positive load plus 72.5 times 4 moment is D, minus downward loads, which is 20 times 4 times 4/2, just that. So it's 72.5 times 6, it is 435, minus 20 times 4 times 2, which is 160. So it's 435 minus answer. We have 227. 275. Let's confirm from this side. Let's just confirm. We have 72.5 times 4, 290. Where is this coming from? Where is this coming from? I just it's 290 minus 160. Yeah, we have 130 kilo. But let's just confirm from this side. So we have reaction A which is 57.5 multiplied by this distance, which is 4. But remember, it's a positive load, so we have 230 is a positive minus now this, which is 50 multiplied by 2, which is 100. So it's 230 minus 100, and we get our 130 kilonewton per meter. Sorry, here it's per meter. You see this is just as easy as that. You have to do prove. Kama umekosea, you start afresh and it will just easy for you. So we have gotten all the maximum bending moment, and now we need to sketch. So sketching, we have to extend this. Yeah, then let's start here. Let's put it here placed. So we have to drop these letters A, C, D, because it will act here. Let's just name it E, and we have B. So we have already calculated, and we know automatically that any beam that's simply supported at the side, at the end, or hinge at the end, bending moment is 0. So here is 0 and here is 0. So bending moment as C, we have bending moment as C, we have just calculated. We have at C, we have 115. 115, let's say it will be here, 115 kilonewton per meter. And bending moment at E, it will be 130 at D, but we know that any span carrying a uniformly distributed load, the maximum bending moment will be occur at the center. That's why I have added this line. So we have 130, 115 is here, let's say 130 is here, 130 kilonewton per meter. Get together. But now you also have to know this, that for a point load, a span that's carrying a point load, the bending moment diagram will be looking like a triangle this way. Triangle. And for a span that's carrying a UDL load, the maximum bending moment diagram will occur as a parabola. Is this a parabola or a semicircle? I don't know, something like that. So it will occur this way, it will look this way. Yeah, then both of them are positive, and then you have to shade. Yeah, it's bending moment diagram, and it's just that simple. So this you should